Hello all, good morning. This is Dr. S. Subbalakshmi, an assistant professor in the Department of Mathematics, SNS College of Technology. This is a lecture video series on the course Differential Equations and Transforms, and now we are on to the topic of Fourier series. Today we are going to have a lecture video on design thinking concept of Fourier series. Second slide. So the first stage of design thinking is empathize stage. In this we will be creating the problem statement or identifying the problem statement. Which is, the scenario here chosen is sound signal processing. Engineers are working on noisy audio signals. This is our problem statement. So, these engineers are working on noise audio signals. We are going to clarify the noise audio signals and segregate the original audio signals here. And what will be the problems observed? What may be the problems observed?
Voice recordings may be controlled by unwanted noises and hard to analyze indirectly.
Yeah, it may be having some voice clarity issues and it cannot be analyzed clearly. These are the problems observed in the received voice signals. And how can we break a complex signal into simpler parts to analyze it, and how can we do it? What is our main aim?
We can do it by using the mathematical ideas and mathematical conditions.
Yeah, this is what our content here is. We are using some mathematical tool or mathematical models to rectify the same. Second slide. This is our define stage of design thinking concept. What is our problem definition? A complex periodic signal is difficult to analyze directly. So, it is given here as it is difficult to analyze directly. Why is it being difficult to analyze it directly?
It is difficult because it contains a noise signal. So, to analyze directly, we use noise signal.
Yeah. It is difficult to analyze because it contains noise signal. So, we are feeling difficulty in segregating the original signal from the noise signal. This is what our difficulty face. And now our goal is to convert the signal into simpler components, which means we are going to break down the components into signals into simpler components and identify the frequency content clearly, and we are going to identify the original content from the sound signal processing clearly out. Next. So this is our ideate stage. What might be the possible approaches in our ideate stage?
The possible approaches are direct time domain analysis, messy, inefficient, and the graphical approximation not precise, and to use the Fourier series.
Yeah, possible approaches are using the direct time domain analysis. We use it directly from the content given and we are analyzing it. That may not be possible here. The second thing is a graphical approximation, which may not also be possible since it contains the noise signals also. And the third is using Fourier series. This is our actual content wherein we apply this mathematical tool to segregate into simpler components. So, why we are using Fourier series here? It converts the given complex signal which contains the noise plus the original frequency into the sum of sine and cosine waves. We already knew that sine and cosine waves are in the waveform like the wave signals. So, this can be communicated with both the noise signals and the sine and cosine signals. Next. So, what is our ideal stage? In this, we will be applying some of the mathematical tools formulae. What is the formula to find the Fourier series which we have learned earlier?
F of x is equal to n by 2 plus summation n is equal to 1 infinity a n cos of nx plus b n sin of nx.
Yeah, this is our formula to find the Fourier series expansion of the given function a0 by 2 plus summation n is equal to 1 to infinity a n cos nx plus b n sin nx. And what is its meaning? The actual meaning of the Fourier series is any periodic signal will be the combination of sine waves and cosine waves. Because we have decided in the first itself, before defining the Fourier series concept, we will be having the Dirichlet condition wherein we will say that given function f of x is periodic. So that periodic function or periodic signal is defined to be the combination of sine and cosine waves. Each term represents a frequency component because this A0 will represent a frequency component, this AN term will represent a frequency component, and of course this BN will also represent the frequency component. Next. So this is our prototype. In Fourier series, what are the coefficients we have?
Ma'am, we have AN, BN and A0.
Yeah, we have A0, AN and BN, and we have separate formula to find the values of the Fourier's coefficients also. So here we are using these coefficients of Fourier series to break the signal into components using the coefficients of Fourier series. We are going to break the signal into some components, and these are calculated using the integrals as discussed earlier. And this is where this theory becomes becomes an implementation concept. Okay, next. So what is the prototype for the given Fourier series mathematical model? In design thinking concept, this is the fourth stage. Compute coefficients for the given signal. So we are going to compute A0, AN and BN and reconstruct the signal using the series. The given frequency of the periodic signal have been reconstructed using A0, AN and BN as defined in the previous slide. And what will be the result form?
Results in complex form has been transformed to simplified frequency components.
Yeah, what we have inferred is the complex waveform have been transformed into simplified frequency components. This is what we aim to. We are going to segregate the original frequency and the noise frequency signals. Next. So this is the test stage. What is this interpretation? The low frequencies are transformed into the main signal and the high frequencies are the noise or the disturbance have been identified and eliminated from the original content. We can eliminate that from the original content. And what will be the outcome? Outcome is noise can be filtered and the signal becomes clearer. So the sound signal processing which contains noise have been cleared or segregated using Fourier series analysis. Next. So in conclusion, what we have regained or what we have gained as a knowledge using design thinking is understood the real world signal problem. We have framed the problem and defined the analysis challenge. What are the challenges faced have been analyzed and selected the Fourier series. We have come across many set of mathematical tools and in which we have decided to use the Fourier series and build a mathematical model. With the help of Fourier series expansion, we have built a mathematical model and extracted the useful frequency information as what we are in need of. So we have extracted the useful signal. Next. And finally, what we have inferred as a result is Fourier series is not just a formula, it is not just a formula, but it is a practical tool used to break down, understand and improve the real world systems. Here the real world system means the sound signal processing. So this is how we perform a design thinking approach on the mathematical modeling. Thank you.